Hello, good afternoon. Today we are going to follow this tutorial, or we are going to do this tutorial, sorry, about custom mark RCNN using Tensorflow Object API. We did one on faster RCNN. We have one on faster RCNN, and we like to do one on custom RCNN for our own images. So the first thing we like to do is to create these folders, or you can just clone the folders, clone the repository and put it in your desktop. So what I did was I got the same folder, I will place my folder in my hard drive C, because it's usually difficult for me to run so this is my folder. You can see it's exactly the same. We have the CP, dataset, extra, pre-trained models, inference graph folder. This one we'll add it while we are doing the tutorial, so it's not that important. To get images, as many as possible, and with different background. The images must be in different background. So these were the images we took. We took these images of a ball. We took 30 images. Now what we'll have to do is to resize the images. Resize the images. So we have the images. We have to resize the images and give it a size 5, 12, and 384. Sorry for this disturbance. 5, 12, and 384. So I have a Python file called transform images. It helps me to transform images from a given file, a given size to a different one. So if I open the file, you can see that it takes the directory and the size as an argument and gives back the size you wanted and where you want the file to be. So we can try it, but I already done it, but you can still do it and see how it goes. Now the name of the file is transform image resolution.py. If we type for help, it will give us the arguments, the usage and the argument. So it takes directory, and then resize. So our directory with the images, the same images, the size, 5 tall by 384. So it's been done. Now we have our images 5 tall by 384. After resizing our images, the next step is to separate the images, 80% for the training and 20% for the testing. So we shall do it. We simply take the images, copy, and you place the images. These are directory repository into the dataset, and you place it into the JPEG folder. Place it into the JPEG folder. So you can see these are images. After doing that, we take 20% and put it into the testing. So these are the testing images. We had 30 images, so 20% of the test will give us 6 images. We have 6 images over in this folder. The next thing to do is to use the pixel annotation tool to provide mask for our images. So there is a tutorial on how to install the pixel annotation tool. This is the tutorial, but I would prefer, instead of using this one, you can go directly to, sorry, I have some pixel annotation tool, the same. You can go directly to this GitHub repository and get this repository and just download the Windows file or the zip file. So I've done that. The name is pixel annotation tool, zip 39 megabytes. So in my download, in my folder, download, how the pixel annotation tool. Pixel annotation tool. So in the pixel annotation tool, where we have to open the directory where the images are, and the directory is mask, the dataset where the JPEG images are. So here we have our images. This one I've done it. I will just show how it's done. So we have to be careful how to annotate our pixel or annotate the images. So we select the image. So this has already been done. I've done for all of them. I'll just take example of an image. We change the directory to, let me select images here. Let me take an example of one image. Okay, this is an image that has not been annotated before. So with this one, we just sorry, 1 second, let me open it again. I don't want to save it in the same folder, so we'll go to desktop, images, and work with these images. Okay, so this is one of the image. What I'd like to do, first of all, we increase the size factor so that you can see the image better. So we increase the size factor 1.5. Next, you select any color you want. I will select red and provide the pixel. After that, I will come and select out of ROY for the background. After selecting out of ROY for the background, I will come and click watershed mask and then watershed. So this is an image we got. Then I will just come and click save current image. I will do that for all the other images. So if you come into the desktop, images, we'll see we have now the pixel, the mask image. So we have to do that for all images. You'll get a folder your annotation folder will be made up of mask, color mask images, and watershed mask. The only thing we need is the color mask images. So you can delete the mask and the watershed mask, or you can just take the mask images and put it into the folder. So this is what we did in this folder. We have our data set, we have the annotations tool, we have the JPEG images. We did it for each and every images, and then we got the color mask images and the color mask images, the mask images, and the watershed images. So these the watershed images. You can delete all watershed images in this folder. Delete watershed. Delete watershed. So we have this folder. We delete watershed images, watershed, all the watershed images. Sorry if it will take time. I like to delete all the watershed images that I obtained. So now we have all the watershed images gone. We'll take the mask images, mask, we have all the mask images. We have to take and place it into the mask folder. So we pick it, the JPEG, our annotations, we put it into the mask folder. Now, these were the color mask images. So what I did was, let me show you what I did. In the images folder, which is on the desktop, we have an example of a color mask image. So what I wanted to do is to save, since the images were many, I wanted to save this image as we are told in the, you need to take all image name color mask and place it into the dataset annotations folder, and then rename it from image color mask to image.png. So add many files. You can imagine, like 30. I couldn't go through each of them and do it manually. So I created another Python file called reading and writing. What it does is takes the images, the color mask images, removes the color mask PNG and replace it with PNG. So it did a good job for me. So after that I got all the images we can see here without having to do it manually. So in the data set we have the annotations. In the annotations we have the color mask images, which have been renamed using the Python file I've just shown. Quite simple. So after that we have to clone the TensorFlow model. This one I had already done it. I did so this is the repository we have to clone. I've done all of this already, and if you like more tutorial about this in particular. I think we have you can follow this tutorial. Take you through how to clone the images, how to clone the Git repository. So sorry, by Git is the one I followed, and you'll get the repository. So this and that, I'd already done it. So next, what we'll have to do is to create mask rcnn TFRecord.py, sorry, and we place it in the repository I have. So let me show you the repository that I have. To the download. Models, research, object detection. Okay, so this is the repository. This is the directory, sorry, that I had for the object detection. So after cloning, this is what I got, and I had everything inside. So we'll take the create pet.tfrecord.py, or what you can do is just clone this repository, and in this repository we have the TFRecord.py mask rcnn. So what I did from the repository, I copied the file, place it in extra. So this is the create mask rcnn TFRecord.py. You can open it. So now what we have to do is to change the mask pixel depending on the number of items we have. We had only one item, and I got it to be bold. I place it to be the bold, and this is the mask, the pixel value. How do you get this pixel value? One thing I failed to mention, from here you can come to extra and run the command prompt, open Jupyter, this one helps us to check the images. So this is one of the images I had in my annotations files. So taking this image and something happened. Okay, there are no more images in this file, sorry. So I'll have to go, since I changed the repository, I have to go to dataset, annotations. This is the particular image we are looking for. You can just go to properties, or details. This is the new folder now. Oh, that folder does not exist, so we just place the folder over here. And we change all the slash. // to backward slash. So now we have the image. So this is the image, and you can pick any. I choose 250 by 250, one of the images, or you can take 200 by 200, 100 by 1, and you get the pixel value. The pixel value is 76. So this is where I got the pixel value, and you place the pixel value in this. So if you add for other items like I don't know, if you wanted to detect a speaker, or you wanted to detect a bottle, you can put it bottle, and you use the same check pixel values file Jupyter notebook, and it will help you to get the pixel value. So this is what we got. So we save the create mask rcnn. We have to save the folder into the object detection notebook. So into extra. Pick it and place it into object detection folder in the dataset tool. Object detection dataset tools. Place it here. So next, one thing we have to add, if we add many images, for example, we have one speaker, two speakers into these images, we need to use the label map, the label LMG, label LMG PY or label LMG file to run detector to drop boxes around the images. Otherwise, the mask will only detect one of the images, and the mask will take all the images like one image instead of all of the items like one item instead of many items. So if you add 4 speakers, we have to use these two, label LMG2, to create boxes for each images, so that the mask will be placed in each image, in each item, sorry. So we can follow this link, it will tell us more about that, but I only used one image, so it was not important. So now we have to we've changed the label map. Now we have to create label map, label.pbtxt. I did that. Label dataset, and we place it in the dataset folder. This is where you place your classes. I only have one class. If I add other classes, I will simply add and this one will be id2 will be speaker. Sorry, speak. I only have one item, so this is not necessary. So now I have my label pbtxt, sorry, file into the dataset. This is my own directory. This directory is different from the object detection directory. So after doing this, we can go ahead and create the test record. So what I was doing, I prepared all my various paths, and I will put it to the folder for us to follow. So now we have to go into the object detection, research, dataset, and run this folder, this Python file, this Python program, create mask rcnn TFRecord.py. Save it into our dataset directory. The annotations will be directed to the annotation directory, the image to the image directory, and the output directory where we want the record file to be saved. And we have to link the label map where the label map file is. So this is what we do. We go to the object detection. This is object detection dataset tools. This is where we have the create mask rcnn TFRecord.py. So from here we'll run. So we go to train our record, Python. Okay, so now we have our train record. And go to the data set and see the train record. Can rename it. So that you can easily use it again. Train record file. No. Come back to the tutorial, the training, after producing the record file, you have to set the training. So you need to go to TensorFlow detection model and download any model you want. So when you go to the TensorFlow model, you can download any model which you preferable to download the mask rcnn inception v2 coco. So after downloading that model, you have to place it into the object detection. This is the model I downloaded. Download, sorry. Mask place it in the object detection folder. Models, research, so now we have it here. You can simply take the folder and paste it into the pre-trained models file. So that's what we did. two-chain model files. We have a mask rcnn inception v2. So next thing is to take the configuration file, mask rcnn, the configuration file, sorry, the sample file, and place it in our repository. So we go to the object detection tool, object detection folder, sorry. We have go to samples, object detection, samples, configuration files. We take the mask rcnn and then we place it into our repository. The next thing to do is to configure the path. Configure all the paths. We have 5 paths to configure in the folder. We have to configure the path, sorry. We go to configuration. So we open the mask rcnn in our folder. Open it, configure it. Okay, the number of classes, we only have one class, which is the bulb. Paths to configure. The first path to configure is find 2 checkpoint, path to be configured, and that path is where the mask, the model C KPT is. So where do you get that model? You go to the dataset, train models. This is where the model is, model C KPT. So we take this path. Remove all the backward slash, all the forward slash, and place the backward slash. This one we are done. Next we go to the train input path. The input path should be where the train record is. How should our file path look like? It should direct us to where the train record is. And that train record is in the dataset, train record. Record. Do the same thing for the label map. The label map where the label map file is. Same dataset folder. So you can copy this and place it in the same folder as this one, the evaluation. Do the same thing for the label map. So we can save a configuration file now. Now that it has been saved, we have to proceed with the training. So for the training, we have to run the training in the object detection folder. So we go to our object detection folder, models, search object detection folder. We have to go where the legacy folder, the legacy file is. Legacy trend. Let's go to legacy. So we have the legacy file here. So all you need to do is to take the train.py file and place it there. But we had placed it in the object detection folder. So it's usually placed in the object in the legacy folder. You just take it and place it in the object detection folder. Now we can run close this one. We can run a command prompt from here. So now we have to start with the training. Our training directory will be, let me just change this to what I have now. The dataset, sorry. So first, train.py. This is where the CP folder is. And that folder is here. Change the / to /. Do the same thing for the pipeline. Configuration file, where the configuration file is here. Just change it. So now we are done. We can just copy this. And run it. So we train the model. Now the training is starting. Oof. The training is starting now. What you can do is to open TensorBoard and see where TensorBoard files. So for us to get TensorBoard, so now we are starting a RAD training in the same object detection folder. TensorBoard. Sorry. So we said we are training. So this directory is where the training will be filed. And it's in this folder. CP. Okay. So it's now even coming. It has started. So login directory. Let's remove all of this. Sorry for this. Go to CP. So we can build. Okay, so change. So now the training is, because it's huge at the beginning, and we'll see for. So this is the local host. You can and open so this is what we have at the beginning and what you're interested in, the total loss. Okay, so we've been training the model for the past 10 hours and the results are still the same. Okay, the results are pretty good. We're expecting to get a value less than 0.2. The value we are getting is 0.406. I'm not sure it's going to get any better, so we'll just save the result here, the training. So what we have to do, we go to the command prompt where we've been running. We could get so 10 hours training with the CPU. If you're using the GPU, it will be much better. So let's go and lock it. Let's save it. I just want to see the last one. Okay, I will save it at this last step, because with the last step it will match. It's quite better. Calling some 385. This is the object detection folder. We go to the research. Object detection. And this is where the export inference graph is located. We have it right here. Export inference graph. So let's go ahead and export inference graph. Now it's rising. We have get the inference graph in this folder. Okay, it's saving. Thing is done. Okay, so now we have our inference graph. We can now open let's close this one. Sorry for this, you go back to the tutorial. So after obtaining the inference graph, all you have to do now is to open Jupyter Notebook. So we go to object detection. Now we have to modify this level to specify the inference graph, the path to the frozen graph, and the training level. So, and the other thing we have to do, if we go in here, we have a modified Jupyter Notebook file. We can extra folder. So we are here. Open command prompt. our mask rcnn evaluation IP. So all we have to make some changes. Path to the frozen graph, we have to write the path where we have our frozen inference graph, and for in our case inference graph is here. This is the path. C mask rcnn with Tensorflow API IG. We do the same thing. We do the same thing for the label map, where your label map is located. The number of classes is 1 because I'm using only one item. So now we can run. And one last thing, the images, the test images where they are located, you have to write the path. C mask, this is where my images are located, so you can run this. After that, we load the inference graph, load the frozen graph, loading the label map, use this code. We run this cell as well, detection cell. Now, as per the list. And we have how many images we have? We have 6 images in our test folder. So we'll expect the mask of 6 images to be detected. It's taking a while. Loading, reading, but we'll get there. You see the images, they appear. So now we have our images, and with the mask. This is the first image we have. I'm going to check in the image. This is the first image that has been produced, and the mask has been found or has been drawn. It has been detected 90%. We have quite a lot of image, a lot of items, but it's the one that's been detected. And this one we can see the mask has been reproduced on the images as well. The same for this, and the same for that, and this one as well. So this is pretty much it. Sorry. The other thing we can do is to get the mask on the video, or so we've been able to use mask rcnn to produce a mask, to detect the object and produce a mask on the item. So now let's try it on a video or on the live feed. We will try it on a video. We have try it on a video. For the video I have a Python notebook, Jupyter notebook, sorry, that I had already written. I'll just go to the object detection where everything is placed. Come to others, model, research object detection. So we have a notebook over here, tutorial. So this is the one we are going to run. So we can just close this one with images. We've been able to detect mask, detect mask. So you can close this and close this one as well. And run this Jupyter notebook. Here's the notebook. Everything is the same. The only thing I added was the same inference graph. We have to change the classes. Number of classes is 1. Download the model. We load the frozen graph. We load the label map. We are not dealing with images, so this one will be left. We are not going to touch it. This one too, we are not going to use it since we are not images. We are going to run this, and video capture. Here we specify the video we are going to load. So I had one video of the images. All I need to do is to go to the desktop where I placed the video. This is one of the video I took for the images for the live video. This is the item. So I'll try and get the mask for this particular item. Or I have another shorter video. So we are waiting for our video to load and for us to see the mask, and great, so we have our image. Sorry for this, it's not responding, it's seeing a lot of white things here. So this is the mask. The video is, we've been able to go through the tutorial and identify and detect the images with mask on them. I will advise you to use the GPU for better recognition, better training and better recognition. I thank you for the tutorial. Thank you for the video, sorry. For the comments, I'm expecting some of your comments, advices and critiques for me to make improvement on the tutorial. I will upload the documents, the files, the transform file, and also the read and write Python file that you can use. And if you're also interested in my older video coordinate detection, I will send the file as well. Thank you.